Hello YouTube, this is Umozo3. We've made it to lesson 3 of the set of YouTube videos that I'm making regarding the Java programming language. So we said in lesson 0 again that BlueJ is an integrated development environment. So a software program, and you can Google BlueJ and you can download a software program that allows you to write Java code. Once you've done that, you can go to my lesson 1 and we learned how to print statements. We learned about the difference between System.out.println and System.out.println. So basically learning how to create a class here by pressing new class at the top left, this yellow box appears. We deleted the standard code here, wrote our own code with system.out.print, system.out.println, and learned that if we have system.out.println, then we print a line of code and then go on to the next line. But system.out.print simply prints code and then just continues on the same line. We talked about single and multiple line comments. So single line comments start with a single slash, multiple line comments start with a single slash and then a star. And then finally, we talked about arithmetic expressions. So we know that Java is capable of doing addition, subtraction, multiplication, and division. In Java, an integer divided by an integer is another integer. So 2 divided by 4 is 0 because there are 0 full groups of 4 in the number 2. But if we want to have perfect division, we need to convert at least one of the numbers to a floating point number. And then we talked again about modular arithmetic, remainders, and the fact that if you have 92% 10, it's not really a percentage, it would return 2 because 2 is the remainder if you try dividing 92 by 10. In this video, we're going to talk about variables because once we start doing arithmetic expressions, once we start saving information and using the same values over and over and over again in Java, it's a helpful paradigm to keep track of things called variables. So variables are basically ways of storing information in Java so that instead of writing the number 326 over and over again, if that's an important number in our program, we could just save that as X and then call X every time. Because maybe X is going to change. Maybe 326 isn't always the number that we're going to be using. Maybe by suddenly it'll change to 329, and then the code will want to automatically update everywhere it's supposed to refer to that number. And so we can do that with a variable. In order to understand variables in Java, we have to understand data types. So there's different data types, and the first one that we're going to talk about is an integer. So an integer is a whole number. So for example, 7, 2, 12, 0, -5, -312, -16,353. These are whole numbers. These are integers. So what we're going to do is we're going to write a line of Java code that does two things. The first thing that it does is it creates a variable, an integer variable called X. The second thing that it does is it's going to give it an initial value. So what we're going to do is we're going to write int x equals 12. So what this does, and I'm going to have a comment here, so I'm going to have 2 forward slashes. Remember that comments can help make code more readable or understandable, but this creates an integer called x and gives it an initial value of 12. Okay, so what we would do is now we can have multiple line comments. So int x, so this is called, so declaration means creating a variable in space. So basically this is where we tell the Java compiler, Java, keep track of an integer called x. And that's what the int x says. It says, Java, I want you to set aside space in memory for you to keep track of an integer, and that integer is to be called x. So x, I need you to just put away some space in memory, and I might put a whole number in there. So it might be a 5 or a 26. And the initialization is the initial value that it takes. So make the initial value of x be 12, the first value that x will refer to. And it turns out that we can actually change a value of a variable after we've already created it, but we'll worry about that in a second. So now if we say system.out.println of x minus 2, what this does is it's going to perform an arithmetic operation. And so x now refers to a number. It's going to say x minus 2, well, what's x? Well, x was taken to be 12, so this should be able to operate 12 minus 2, and we should expect, we can write a comment, that we expect this code to return 10. So what we're going to do is we're going to press compile in the top left and then close. And now we can right click on our class. We can see the drop down menu, press void main string args plus the blue OK in the bottom right. And indeed we get 10 because 12 minus 2 is 10. So this is an example of a variable, and this is a way that you would keep track of an integer variable that you can use throughout your code, and then you could use it in a different way. So now you could use it some other way. So we talked about order of operations. So for example, if you had x plus x times x, what would this do? Well, this would do, right, 12 plus 12 times 12. The question is, do we do the 12 plus 12 first and then multiply that result by 12? Or do we do 12 plus whatever 12 times 12 is? And the answer is the second one, right? So that respects order of operations. So we know that 12 times 12 is 144. 12 plus 144 is 156. And so this is just another example of how variables can be used in Java. And that's the output that we would expect. So that's why you can see a 156 on the left. And of course, the 10 is still there because we never deleted this line of code where we have x minus 2. So that's an example. That's declaration and initialization of a variable. You can change the value of variable after you've created it. So what if you say int b equals 4, System.out.println of b. So of course this would print 4 obviously, but now you can say b equals 10, System.out.println of b. So you've written System.out.println of b twice in your program, but that doesn't mean that it's going to output the same thing both times. So you should see 4 on the first line and 10 on the second line. Something that you can do in computer programming, but you can't necessarily do it in algebra, is you can reassign the value of a variable according to an old value that it's already taken. So for example, what if you have int t equals 3, and then you say t equals t plus 1? Algebraically, can you think of a number that's equal to 1 more than the number? No. 4 is not equal to 5, 9 is not equal to 10, 22 is not equal to 23. It doesn't make any sense, but this is an assignment operator. So it says assign t to be whatever the old value of t is plus 1. So what this would do, so t is now 4, right? So now what we would go ahead and expect here is System.out.println of t, and we should expect, that 3 plus 1 is 4. So it's okay to say t equals t plus 1, because remember, this equals sign here, be careful when you say equals, right? Because we're not saying equality. We're not saying algebraically it's always the case that a number is equal to 1 more than the number. It's not saying that two things are equal. It's doing an assignment. So it's saying assign t to be whatever t is plus 1. So that's what happens here. And so the value of t is just going to get updated here. So that's pretty, and then you can have more than one variable too. So you could say in x equals 12 and y equals 9. And then obviously if you say System.out.println of y minus x, 9 minus 12, of course, Java can do negative numbers, of course. So we would expect -3 because, if we have 9 and you take $12 away, you're going to be 3 in the hole. So we get -3, and Java is very comfortable with that. So those are integer variables. We can also think about double variables. So we also talked just very, very, very briefly about floating point numbers, decimal numbers in Java. And we know that Java is capable of doing that. So we didn't explicitly say this in the previous video, but in the previous video, you can add floating point numbers together, right? So 1 plus 1.2 plus 2.4 is 3.6, that's fine. And you can have something called a double. So a double is the data type that refers to a decimal number, a floating point number. So if you say double r equals 5.8, and now you say System.out.println of r plus 1, you should expect 3.6 on the first line because 1.2 plus 2.4 is 3.6, and 6.8 on the second line because 5.8 plus 1 is 6.8. So we see an interesting result here. You see a 3.599999996. So that's actually a rounding error. It's basically a rounding rounding operation in Java, okay? But that's close enough to 3.6, but that's just basically what happens with the computer output. But this is what we would expect, right? And you could have different double variables. So you could say double A equals 6.0, double B equals 2.0, and double C equals 1.0, right? And so what if you said System.out.println of A plus B plus C? And you would think to yourself, well, 6.0 plus 2.0 plus 1.0 is 9.0, which is sort of an integer, right? It's 0.0, it's sort of an integer, right? There's really no remainder, right? But you're still going to get 9.0 because what we said in the previous video is that Java prefers floating point numbers over integers, okay? So what if you have something like double x equals 50 and you say, wait, I thought 50 is an integer. Shouldn't we say int x equals 50 or double x equals 50.0? Okay, so we can certainly assign integers to ints and we can assign floating point numbers to doubles. It turns out that you can also assign ints to, you can assign integers to doubles, okay? Because basically what happens is there's going to be an automatic conversion to 50.0. And if you want to get technical, this is called an implicit cast. So it's implicitly converted to 50.0 because we're telling Java that x is to keep track not of an integer, but of a floating point number. So if you feed it a 50, it just says, oh, you mean 50.0, because it's being treated, it's being represented as a floating point number. So now if you say System.out.println of x, it's not just 50, it's 50.0. You cannot have it go the other way around. So if you say int d equals 6.0, there's going to be an issue here. There's already an issue. It doesn't even run. I tried to compile it, and you see an issue here, and BlueJ tells you the issue. So it says incompatible types, possible conversion from double to int. So you can't force a floating point number into an integer, even if the floating point number is a 0.0. Okay, so this is a problem. So this is a problem, and so you basically comment out this line of code, and instead you would write double d equals 6. And then so this is an implicit cast to 6.0, like we saw a minute ago, with the 50 being converted to a 50.0. So now what you do, so now if you went ahead and say something like double x equals 4, you know, System.out.println of x times 5. You know, 4 times 5 is 20, but 4.0 times 5 is 20.0. And that's what will be printed here, 20.0. Because even though you're multiplying with an integer, Java prefers the doubles. It does an implicit cast to a double. So once you have a floating point number in here, the result is going to be a floating point number. What we haven't said, and then you can do this with modular arithmetic too, right? Int t equals 82, and then you could say, you know, int u equals 20. You know, you could say something like System.out.println of t mod u. And then of course this would give 2, right? Because if you divide 82 by 20, we would expect a remainder of 2, and certainly that's what we get here on the console output. You can explicitly convert a data type of a value or number. So you could say something like int a equals int of 6.7. What this does is it converts 6.7 to the integer form of 6.7 and assigns that result to a. So assigns the integer 6 to the variable a. Okay. And now if you said, what if you said double b equals int of 8.2? So this would be assigns the double 8.0 to the variable b. Why? Because 8.2, when you cast that to an int, it becomes 8. But if you feed an 8 into a double, it's implicitly cast to an 8.0. So this again will be 8.0, but then this one will be 6, and we can print these variables at the end and make sure that this is what we get. what if you have something like this? So you have System.out.println, right? If you said int, what if you convert an int 3.2 over 4, right? So then this just becomes 3 over 4, which is 0, right? It's a integer division, integer-based division, integer division. Okay, so that would be 0. But then if you go ahead, we can print these variables too, right? So we want to print A and hopefully get 6 on that line, and then we're going to want to print B and hopefully get 8.0, and then we'll see a 0 here. But then what if we convert one of them to an integer or to a double, right? So what if we do 75 divided by double of 100? So now this should be 0.75 because 75 divided by 100.0 is 0.75. As long as you're working with one floating point number, Java is able to do the perfect division. So hopefully that gives you a sense of these types of data types and the conversions. And what you want to be familiar about with for this video is that variables allow us to keep track of important values in a program, and that's why you want to have them. But be careful about where you use variables, because if you think about good programming practice, if you only use a value one time, you want to hard code the value, right? You don't want to create x equals 292 if you're only going to use the number 292 one time, because then you're just taking away space and memory to keep track of x when you really didn't use it that much. But if the 292 is a really important number, then say x equals 292. So instead of remembering 292, you can just write x. And then we talked about ints and doubles in a little more detail here. And we said ints are used for integers and doubles are used for floating point numbers. And so doubles are preferred. Okay, so 6 can be converted to 6.0 automatically, okay, but 9.0 cannot be fed into an int. So again, let's think about the output here. So hopefully if we understand conceptually, A will be 6. If we print B, we get 8.0. Here we should get 0, and here we should get 0.75. So we can just go ahead and run that for now. And those are exactly what we get. In the next video, we'll talk a little bit more about variable declarations and changing the values of variables, a couple more strategies, and just to be able to review these techniques before we get into some more advanced topics. From UMills03, thanks for watching, and please subscribe.